Welcome aboard, crew. I am your host and lead pilot for today's journey, and I've got to say, I am absolutely thrilled to have you strapped in for this one. Right now, you're standing on a planet that probably feels enormous to you. It's this 12,742-kilometer world of oceans, mountains, and nearly 8 billion people. But what if I told you that our home is so tiny compared to the rest of the cosmos that it's almost impossible to even imagine? Well, today, we're taking this explainer on the ultimate expedition. We're flying from Earth all the way out to the very edge of the observable universe, just to discover how incredibly vast our cosmos really is. So, just to prep your inertial dampeners for the massive leaps in scale we're about to face, let's take a quick look at our mission flight plan. We'll start with departure from planet Earth, then navigating the solar system, followed by crossing the Milky Way. From there, we'll scale way up to the cosmic web, push out to the observable universe, and finally, we'll attempt to reach the uncharted edge. It is going to be one breathtaking ride. Okay, let's dive into this. Phase 1 of our launch sequence. Section 1, Departure. Planet Earth.
Down on Earth, our world feels pretty massive, right? I mean, flying around it takes hours, and driving across its continents can literally take days. But looking out the viewport right now, it's just a speck. Our first true navigational marker out there is the Moon, sitting 384,400 kilometers, or about 239,000 miles away in the dark. That right there is the distance of our absolute closest cosmic neighbor.
Just to ground our instruments before we hit light speed, let's check our flight simulations. If you hopped on a regular commercial airliner and flew to the Moon, it would take you nearly 3 weeks without stopping. But if we look toward the Sun, which is a whopping 150 million kilometers away, it's a completely different story. Light, the absolute fastest thing in the universe, takes just 8 minutes to reach Earth from the Sun. 8 minutes. And crew, we are only just getting started.
Main thrusters engaged. Section 2, Navigating the Solar System.
We are currently blowing past Neptune, which is 4.5 billion kilometers out, and plunging straight into the uncharted outer regions. We're talking past the Kuiper Belt and into the mysterious Oort cloud, this gigantic shell of icy objects. Out here, normal math completely fails us. I actually need to consult our ship's navigational manual for a brand new metric, the light year. And it's super vital to remember that a light year is not a measure of time. It's the physical distance that light travels in one entire year. So, the crucial point is, that means one single light year is a staggering 9.46 trillion kilometers, or, for my miles folks, 5.88 trillion miles. Astronomers use this measurement because, honestly, ordinary kilometers are completely useless for our navigation now. I mean, the Oort cloud we're flying through right this second, it might extend nearly one full light year away from the Sun. Zooming out even further, we arrive at Section 3, Crossing the Milky Way.
Our solar system is just a microscopic speck in this massive spiral. We are surrounded by hundreds of billions of stars, and scientists believe there could be hundreds of billions of planets right here in our own galactic neighborhood. If I were to push our ship to maximum warp, literally matching the speed of light, the absolute fastest speed allowed by the laws of physics, it would still take us 100,000 years just to fly from one side of this galaxy to the other. The Milky Way is 100,000 light years across. No way around it.
Amidst all that massive, violent scale, let's just take a peaceful moment. Our tiny solar system is located about 26,000 light-years from the galactic center, just quietly orbiting the galaxy once every 225 million years. It's this beautiful, quiet rotation in an incredibly vast neighborhood.
Leaving our home galaxy in the rearview mirror now, let's move to and see how this builds. Section 4, the Cosmic Web. We're setting coordinates for our neighbor Andromeda, which is 2.5 million light-years away. Crazy thought. The light reaching Earth from Andromeda tonight actually started its journey long before human beings even existed. As we accelerate, let's map out our expanding cosmic flight path on the monitors. We started our local group, a family of more than 50 galaxies that includes the Milky Way and Andromeda. But that's just a tiny neighborhood. We scale up into enormous galaxy clusters, then superclusters. And finally, step 4 on our cosmic address, we see the universe's grandest structure, the gigantic cosmic web just stretching across the void. Just marvel at the view from the cockpit for a second. Scientists estimate that this cosmic web contains hundreds of billions of galaxies, and inside each and every one of those galaxies are billions or even trillions of stars. It's just a breathtaking realization of how much is truly out there. All right, crew, brace yourselves. Section 5, the observable universe.
Now, what's really interesting about this slide is our ultimate sensor sweep distance is pinging back a number that completely defies comprehension, 93 billion. The observable universe is roughly 93 billion light-years across. Take a moment to just let that number sink in.
But wait, this brings up a massive navigational puzzle. We know the universe is about 13.8 billion years old, right? So how can the observable universe be 93 billion light-years wide? How can we observe something wider in light-years than it is old in years?
Well, the answer to that puzzle is basically our greatest navigational hazard, the expansion of the universe. Ever since the Big Bang, space itself has been stretching. So while light has been traveling toward our telescopes for billions of years, the very galaxies that emitted that light have kept moving farther and farther away. Our destination is actively moving away from us as we fly toward it. That makes the observable universe vastly larger than you might expect.
I am powering down the main thrusters. We've reached the absolute limits of what our sensors can detect. Section 6, the uncharted edge.
Looking out into the total dark here, it forces us to ask the ultimate question. Does the universe have an edge? Is there an end to all of this? Scientists have scoured the cosmos looking for some sort of boundary, but so far, they've found absolutely nothing.
Let's review the two leading navigational theories from the scientific archives. Theory 1. The universe is finite but has no edge. Think of it much like the surface of the Earth. If you traveled in one direction forever, you'd never find a stopping point. Theory 2. The universe is actually infinite, stretching endlessly in every single direction. The truth is, at this exact moment, no one can say for certain.
Let's look at the recap of our journey on the monitors. We started on a tiny 12,000-kilometer rock called planet Earth. We pushed through the solar system, crossed the 100,000 light-year expanse of the Milky Way, and scaled way up to an observable universe 93 billion light-years across. And honestly, the most incredible part? That 93 billion light-year expanse might just be a tiny fraction of the whole thing. Beyond what we can see, there could be countless more galaxies forever beyond our reach.
Every powerful telescope we build, every space mission we launch, it teaches us something unexpected. The universe reminds us that no matter how far we fly, there's always something bigger waiting beyond the horizon. Thank you for flying with me on this explainer, but before you unbuckle your harnesses, I want to leave you with this. If our 93 billion light-year universe is just one tiny, finite bubble in a much larger, infinite ocean, what else is out there swimming in the dark?